Alright, so look at this question, very easy. It says if two marbles are drawn one after the other without replacement from a bag with different marbles of different colors. Suppose further that the bag contains 200 red balls and red marbles and 300 yellow marbles. If the two balls are drawn without replacement, which they said before, then the probability that the second, that is A now, the probability that the second marble is yellow, given that the first marble is yellow. So you can see how easy this is. It's, if you watch the previous video, this statement is already the answer basically. So they are saying that without replacement, meaning that if you pick the first marble, you drop it on the table, and you pick the second marble and you drop it on the table, but the first marble has to be conditioned, tied to this one. If you get anything that is not yellow, then you can't proceed. You have to get yellow first before you get the second marble. So meaning that what's the probability, this question now, can you write the conditional or the probability conditional statement? Give it a try. So the conditional probability statement, what is the probability that the second marble, so meaning our answer, the second marble is yellow, given only that we have already picked the first marble as yellow. Very simple. So this is the conditional. So basically this a, you can write this A as this and delete this. So to solve this now, find the probability that the second is yellow, given that the first is yellow. Very easy. All you need to do is to write the formula, just merge them. So write the formula, and then you multiply the probability of yellow second and then yellow first. So that is the probability of getting yellow, right, times the probability of getting yellow second, right? So we're merging them, and this must be equal to what? The probability of getting yellow first multiplied by the probability of getting yellow second. Probability of getting yellow second, like this, right? But we are talking about the conditional probability. That's the probability that this first one, this second one is yellow, must be true only when that the first one is yellow. And here the probability of us getting this first yellow is only true if we have gotten the second, like this. So once you have done this, this must be equal to this. So this is this side I'm talking about. We'll merge these two, and then plus equal to the reverse when you reverse this and this and merge it. So that is the formula. Let me go right again. So what I did here was the merging of this and this must be equal to the reverse. When you put y1 here and put y2 here, and when you merge them, you should still get the same thing. So this is what we are doing basically. So now this is what we are looking for, this probability of this, right? So now all you need to do is just divide both sides by this. So once you do that, this one will be divided by this. So that will be p y1, probability of getting the first one, and so cancel out, and this probability of getting y as first one. So you can reduce the formula like this. So the probability of getting y1 like this merged with the probability of y2, what is common between them. So, or if you don't want to write it like this, you can write it like the probability of getting y plus the probability of getting y2. So you can see that we have just reduced the probability like this. So anytime you have the probability like this, where we have what's the probability of getting y2 giving y1, is very simple. You can just use this instead of that long method formula. So let's see how that works. Also, what's the probability of getting yellow first? That will be 300 over 500, right? But after getting this now, what's the probability of getting yellow second? So now this is the probability of getting yellow first. Now without replacement, so we have picked yellow first. So we have 300 plus 300 as the probability. So the yellow will now change to 299 out of the total, because we picked that yellow and we're not replacing it. We have to drop it down. So this is the probability, but it's the number will change now. How many yellow do we have now? We have 299 yellow. So we still have 200 red. This is second pick. This is the first pick. Second pick is going to be here 299 out of how many? So total will be, the new total will be 499. So the probability of picking the second now as yellow will be 299 over 499. So here now will now be 300 over 500 times 299 over 400. This now will now be the probability of getting yellow first. That's 300 over 500 times or multiplied by the probability of getting yellow second. That's 299 over 499. And what's the probability of picking yellow as first? So for this now, all we need to do now is just rewrite it. So this here now will now be 300 over 500 times 299 over 499 times, switch this 500 because you divided it. Now be, if you want it to be multiplied, you swap it. So this die with this and this will cancel this. So this is your answer. So now I know that process was a bit bulky using the formula, but that's how to do it. Every time, once you identify that, once you've gotten the conditional statement, that's the hardest part. The easy part is just using the formula. So once you get this conditional statement, you put in the formula, and then you can use other methods. But another way to see it is, what's the probability of picking the second as yellow, given I already picked the first one as yellow? It's very simple. If you pick the first one as 300 over 500, it means that the second one, meaning that we've picked one ball. If you pick one ball from here, that would be 299 out of 500. So if you pick yellow, that will be 299. It will drop the total to 499 out of 500. So the probability of picking yellow will now be 299 over 400. So that's a 60% chance of picking a yellow first and picking a yellow again. That's the 60% chance, which is kind of high, depending on what you are doing. So let's try another one so it's more obvious. So look at this one. What is the probability that the second is red, given that first is yellow? So write the conditional probability statement. Probability that the second is red, that means we want red, given that the first is yellow. Like this, first is yellow, second red. So let's replace the statement with this. So to solve this now is very easy. All you need to do is, there are two methods. Either you use the formula directly, the easy formula, or you can use the intuitive way, but let's do it first with the formula. So the formula now will be, the probability of this now will be equal to merge the two of them in reverse. So that is probability of getting yellow, y1 first, right, multiplied by the probability of getting red second, divided by the probability of getting y1. So this is what the formula will give you. So the probability of getting the first as yellow. So what is the probability of getting the first one as yellow? Simple. Nothing has changed, just 300 over 500. So here 500. So here will be 300 over 500. Exactly. And they cancel out. So we're left is what's the probability of getting second as red when we have the first one. So if you pick yellow the first time, we'll get 300 over 500, right? But the total has reduced because we've picked yellow at first, so that's the probability. So the new total will now be 499, and the probability of picking red was untouched, so it's still 200. So the answer will be 200 over 499, or 0.40. So that means we have a 40% chance of this occurring.